Hello everyone. Today we are going to discuss lecture number 15, single phase induction motor. In this lecture we are going to discuss the capacitor start and capacitor run induction motor. This motor is identical to capacitor start induction motor except that the starting winding is not opened after starting. Therefore, both the windings will remain connected to the supply when running as well as starting. There are two designs given for this type of motor. In the first design, the single capacitor is used both for starting and running, as shown in the figure. So there one capacitor is there. It is used for both starting and running, and it remains connected in both the cases while starting and running condition. This design eliminates the need for centrifugal switch, and at the same time it improves the power factor and efficiency of the motor. While in the other design there are two capacitors C1 and C2 used in the starting winding. As we can see in this figure, there are two capacitors connected. Both are used in starting winding. These two capacitors are in the first capacitor. The smaller capacitor C1 is required for optimum running condition, and it is permanently connected in series with the starting winding. The much larger capacitor C2 is connected in parallel with C1 for optimum starting, and it remains in the circuit during starting only. The starting capacitor C1 disconnected when the motor approaches to about 75% of the synchronous speed. The motor then runs as single phase induction motor. So the basic difference between capacitor start and capacitor run induction motor and simple capacitor start induction motor is that there are two capacitors required, one for starting condition and the other one is for running condition. So starting capacitor mainly connected during the starting condition, and when the motor picks up the 75% of the rated speed, the starting capacitor is disconnected while the running capacitor remains in the circuit. So this improves the torque, and it improves what characteristic it is having. The starting capacitor can be designed for perfect two-phase operation at any load. The motor produces constant torque and not a pulsating torque. This is the main characteristic of such kind of induction motor. Because a permanent capacitor is connected in the circuit, therefore the torque remains constant throughout the operation. Because constant torque, due to the constant torque in the motor is vibration free. So it is not vibration is very less in such kind of induction motor, and due to this characteristic it is very much important and very much useful to use such kind of induction motor in various kind of applications like hospitals, studios and other places where silence is important. These kind of places we can use such type of induction motor. This is the phasor diagram. We are having almost 80-degree phase difference between starting winding current and main winding current, and the torque slip characteristic is almost similar to the previous induction motor, single phase induction motor we have studied till now. The only difference is that a constant torque is maintained throughout its operation. So this is all about capacitor start, capacitor run induction motor. Then we will discuss capacitor run induction motor in the next lecture. Till then, goodbye. Thank you.